Hi, welcome to WOW TV. My name is Angel and I'm here from the Wizards of Wright program. The WOW program is a part of the Educational Outreach Office here at Wright-Patterson Air Force Base. Today you're joining me for a lesson on reaction chemistry. Are you ready to get started? Let's go! Energy comes in many forms. Maybe you've already heard of kinetic energy and potential energy. Kinetic energy is energy in motion, and potential energy is energy that is stored. Think about a butterfly or a bird. They can have both at the same time. They have kinetic energy while their wings are moving in flight, and then potential energy due to its position high up in the sky. There is another kind of energy that we will talk about today, and that is chemical energy. Chemical energy is released when chemical bonds are broken. Molecules have kinetic energy. They are never still. They vibrate and rotate and stretch and bend. The bonds between atoms have potential energy. Thermal energy or heat can be used to access this energy by breaking the bonds. When we eat food, we are gathering and storing chemical energy. We burn the calories in our food to keep warm, while it provides us the energy to run, jump, and play. Plants take energy from the sun through photosynthesis. We can then turn plants like sugarcane into ethanol fuel to drive a car. During these kinds of reactions, some energy is typically lost or gained in the form of heat. We have names for reactions that either gain or lose heat energy. Let's consider a phase change, or a change from solid to liquid, and then to gas. This is called an endothermic process. Heat has to enter the system for the change to occur. If our changes move through the phases in the opposite direction, starting with a gas, then to a liquid, then to a solid, heat exits the object. This is called exothermic. Let's use ice as an example. Ice melts as it absorbs heat from the atmosphere around it. When deciding what type of a reaction is occurring, think to yourself, where does the energy come from and where does it go? We can actually use probes and sensors to track the physical and chemical changes during reactions. Our first experiment will be to show exothermic reactions and catalysts. Teachers, we've sent you the supplies to run this experiment if you'd like. If not, we're happy to do it for you. Be sure to put on safety glasses first. And before you start, mix 100 mils of warm water with 1 packet of yeast in a beaker and then set it aside. This needs to be prepped early. Now, first put flask number 1 on your tray and add 100 mils of hydrogen peroxide. Use the markings on the flask to measure it. You are probably most familiar with hydrogen peroxide because you've put it on wounds and cuts. The hydrogen peroxide immediately begins to decompose. The decomposition reaction means a single compound breaks down into 2 or more compounds or elements. The bubbles you see when you add the hydrogen peroxide to a cut is a sign of that decomposition. The O2 formed is what kills the bacteria through a process called oxidation. The walls of the bacterial cell are destroyed. The rate or speed at which hydrogen peroxide decomposes is just very slow. Let's speed this process up using a catalyst. Teachers, we're going to have you run an activity in your classroom. Let us explain the directions first, and then you can give it a try. Student 1 will sit on the floor. Student 2 should attempt to pull them across the room. That's probably not very easy. What we need is a catalyst, something that stimulates or motivates the activity. Now, have student 1 sit on a scooter and have student 2 pull them across the room. Of course, you'll want to discuss what was different and how it worked. Teachers, you can have other students demonstrate this as well. Go ahead and complete this activity, and we'll meet you back here when you're ready. How was that? Now you see how a catalyst works. A catalyst is something that makes the change easier with lower energy input. There is a certain amount of energy required for a reaction to occur. This is called the activation energy. It can be thought of as a barrier to a chemical reaction or a hurdle that must be crossed. If the barrier is high, few molecules have sufficient kinetic energy to collide and cross the barrier. reactants with energy lower than activation energy cannot pass over the barrier at all. Let's think of it this way. Imagine you're trying to push a giant boulder uphill. That would be a difficult task. A catalyst provides a lower energy route for that reaction to occur. The different route allows the bond rearrangements needed to convert reactants to products to take place more easily, with a lower energy input. In other words, it's like using a ramp or a bridge to complete the task. So, the presence of a catalyst allows a greater amount of the starting material to pick up sufficient energy to pass over the barrier and become a product. In this way, the catalyst increases the rate of a reaction. It's important to know that the catalyst does not undergo any permanent change, and it is not actually used up in the reaction. So, let's go back to that experiment we started. The reaction we will show is exothermic. Heat energy is put out. Some examples include freezing, condensation, burning, and rusting. Our next step is to use the beaker with 100 ml of warm water and yeast that we previously mixed and set aside. Now, here's where things get fun. Let's connect the vernier temperature probe to the laptop and place the thermometer into flask number 1, the one with the hydrogen peroxide, and hit the collect button. Can you see the results on the screen? Since the reaction is going at a slow rate, we see very little change in the temperature. So let's add some catalyst and see what happens. We'll slowly add 50 ml of the yeast and water mixture to flask 1, a little bit at a time. Do you see the temperature increasing? Now, let's make this reaction a little more dramatic. Mix a teaspoon of dish soap and 100 ml of hydrogen peroxide in flask number 2. Then, pour the remaining warm water and yeast into flask 2 quickly and stand back. Since a gas is being formed, we can use that to do the work of making bubbles. Okay, we've given you an example of an exothermic reaction and shown what a catalyst can do. Now we'll show you an endothermic reaction. In the exothermic example, heat exited. This includes examples like the burning of coal, an iron fence rusting, and making ice cubes. Now, for the endothermic example, heat or energy will enter our object. This includes examples like frying an egg, sweating, and photosynthesis. Teachers, again, you have the supplies to run this experiment if you'd like. If not, just keep watching us. The temperature probe needs to be wiped off and then placed in flask number 3 with 1 teaspoon of sodium bicarbonate, which is regular baking soda. Hit collect so the sensor begins to collect data. Can you see that? Now use the graduated cylinder and slowly add 50 ml of vinegar. Can you see the temperature decreasing? We're forming a gas in this reaction. The solid sodium bicarbonate reacts with the liquid vinegar and produces carbon dioxide gas. The energy created from chemical reactions can be used to do work. Think of a rocket ship taking off. When a phase change occurs and a gas is created, we have the same number of molecules we started with. However, the new product takes up more space. We can use the volume of the gas created to do work. Here we have a balloon with 1 teaspoon of sodium bicarbonate in it. Add 25 ml of vinegar to a test tube. Fit the balloon over the top of the test tube. Now, lift the balloon so our ingredients mix and watch what happens. The gas created has a larger volume than the reactants. The gas expanding creates a force that inflates that balloon. You will now do a similar reaction to propel a film canister rocket. Teachers, let me go over the directions and then you can have your students get with a partner as you pass out materials. There are a few safety rules you need to follow. Number 1, safety glasses must be worn. Number 2, directions must be followed. And number 3, you should constantly be aware of the rockets popping around you. Each group will need safety glasses, a tray, a graduated cylinder, and a film canister. Teachers will pause for a minute while you get these things passed out and while you fill each group's graduated cylinder with 100 ml of water. Let me explain something very important. The amount of water that you have in your graduated cylinder will be used in multiple trials. You should not use it all in one test. Here's a hint. You should actually end up with some water left over at the end of all of your tests. When you begin your experiment, please do all of the work on the tray. This will get messy. Let me walk you through a dry run so you understand the procedure. You'll carefully add some water to the film canister and then add a tab to the canister, seal it, and immediately turn it upside down. Place the canister on the tray, stand back, and wait. Once it is popped, you should quickly remove the tablet from the water so that it can be used again. You should experiment with the amount of water added to the film canister for each trial. Each tablet should provide about 3 pops. Teachers, when you're sure that your students understand all of the directions, then give each pair 2 of the effervescent tablets. Go ahead and pause, and I'll see you back here when those tests have been completed. Well, how was that? I can tell you that the first few times I did this experiment, I definitely jumped and screamed a little. If you haven't yet, please clean up your area and the trays. You all did a great job today. Thanks for joining me. And teachers, thank you so much for using this WOW lesson. Please check out more at our website at wpafbstem.com.